Okay, so I wanted to introduce the concept of a serial dilution. Serial dilution is just a series of dilutions strung together. It's a way that you can get a very large-scale dilution without losing accuracy. All right, so if you needed to do, say, a million-fold dilution, so you wanted to start with something and make it a million times more dilute, it would be really difficult to do that in a single dilution step because you'd be, unless you were making, a million liters of something, right? You'd end up needing to pipette something that was such a small volume you couldn't pipette it accurately. In general, when you're doing dilutions, you don't really want to pipette something smaller than, say, 5 microliters. All right, and you also don't want to blow through your stock and make a huge volume of your dilution when you're only going to use, a milliliter or 50 microliters. So when we run into a situation where we need to do a very large dilution, and we don't want to make a huge volume of it, we do a serial dilution. All right, and the way that works is essentially you break your dilution up into steps. Okay, so let's say I have something and it's at a concentration of 1 million mgs per mil. Okay, and I want to make it diluted down to 1 mg per mil. Okay, we talk about that in terms of fold dilution. This would be a million-fold dilution. It's going to end up being 1 million times more dilute. All right, in terms of our equation, right, remember C1 V1 equals C2 V2. And when we're talking about fold dilutions, that's really C1 over C2 would be our fold, right? So we'd start with 1 million mgs per mil, we'd end up with 1 mg per mil, and that would be a million-fold dilution, all right? Fold equals C1 over C2. All right, so if I gave you a question and I told you the folds, and I didn't give you these numbers, as long as you kept the ratio of C1 to C2 at 1 million, so you could plug in 1 million for C1 and 1 for C2, or you could plug in 1 for C1 and 1 over 1 million for C2, right? You still have that ratio. That's fine. So you can plug stuff in as you like for your equations. All right, so let's say I want to do a 10,000 fold dilution. And I only need a milliliter of my final solution. So instead of trying to do a 10,000 fold dilution all in one step to make a milliliter, which would require me pipetting, 1/10 of a microliter, which would not be accurate at all. Instead, I'm going to do it in 2 steps. So I'm going to do a 100-fold dilution followed by another 100-fold dilution. So in serial dilutions, you multiply your dilution factors, your folds, together to get the overall fold or the overall dilution. So a 100-fold dilution and another 100-fold dilution, that is a 10,000-fold dilution, or 100 times 100, okay? So in reality, what would I do? I would take my starting stock of purple stuff, let's say, all right, and then I do a 1 to 100 dilution of that. All right, so maybe I add 10 microliters of my initial solution, and I add 990 microliters of water. Okay, so 10 in 1,000 total, that's a 100-fold dilution. Okay, now get rid of your stock tube. We're done with that, okay? Put that away. Now I take this and I dilute this 100-fold. So I'll take 10 microliters of this diluted purple stuff, put it in a new tube with 990 of new water, right? And now I end up with something that's hardly purple at all, just a little bit of purple, okay? And so I did 2 100-fold dilutions back to back, and now I've ended up with a 10,000-fold overall dilution. All right, so with serial dilutions, the 2 important things to remember are, 1, you multiply your dilution factors or fold dilutions together to get the overall dilution or overall dilution factor. And the other is that In order for that to make sense, you have to take from one tube, dilute it, now take from this newly diluted tube and dilute that, use that for your next dilution, okay? Some people get confused and continually take from the original stock, and then you're just doing the original 100-fold dilution every time. You're never multiplying that dilution. All right, hope that helps.